All right, this is our last video tutorial of Lab 3. And in this video, I'm going to show you how to measure the size and phase of Venus. And we're going to do this for a series of images, beginning with the image of Venus that you collected in Lab 1. Now, if you didn't get one in Lab 1, not a problem. Sometimes Venus is too close to the sun. You may not have gotten one. But we will then continue and do this with a collection of images that we at Skynet have already taken for you of Venus over the course of its entire orbit. The question is, orbit around what? If Venus is orbiting the sun, we live in a heliocentric universe where all the planets orbit the sun. And this results in a particular pattern of sizes and phases for Venus. Or maybe Venus orbits the Earth. In that case, we would be living in a geocentric universe, which is what the ancient Greeks believed. And in that case, everything orbits the Earth. And that results in a very different pattern of sizes and phases for Venus. So by measuring the size of Venus and the phase of Venus over the course of its orbit, you can distinguish whether we live in a heliocentric universe or a geocentric universe. And this is exactly what Galileo did in 1609. So you're about to repeat a rather famous experiment. So I'm going to share my screen. Okay, here we are in Afterglow. And the image that we're looking at is the image of Venus that I took for Lab 1. And you can see I have a series of images, 7 other images already loaded. And these are the archival images that Skynet has already taken for you. You can find them by going to Data Providers, go into the sample directory, then into Astro 101 Lab, and Lab 3, and down to Venus. And you can see here they are. Just select them all and import them. I've already imported them, so I'm just going to go back to the workbench. Now, what we're looking at is primarily sky glow. Venus is very bright, and that light, as it comes down through Earth's atmosphere, gets scattered all over the place. And as we learned in Lab 1, if we want to see the planet, we have to change the brightness and contrast settings. So if we come up here to the presets, select Bright Target, and we get rid of that sky glow, and we're looking at the planet. So you can see that when I took this particular image, Venus was a crescent in shape. So to measure its phase, we have to measure 2 things. We have to measure how big it is going across here. That's the short distance, and we call that the illuminated angular distance. And then we need to measure the size of the planet from tip to tip, here to here, and that is the angular diameter. Okay, so to do this, we go to the ruler tool, and you want to make sure that centroid clicks is off, not turned on, because we're not trying to centroid on a moon or on a planet. We're trying to measure the extent of an object, so make sure that is turned off. And then you click on one side, kind of find the edge. We'll do the short distance first, the illuminated angular distance, and then go to the other side. And it's a bit of a judgment call where the edge is. The atmosphere blurs this out a little bit. And so you're going to have to pick a particular shade of gray that you consider to be the edge. And this is a little bit arbitrary, so it's something you can talk about in your sources of error. Okay, I've done this, and I measure 9.7 arc seconds. We can round it off to the first decimal point. And you can enter this into your lab. I'm also going to put it in a spreadsheet that will make it easy to copy and paste into the plotting tool in just a moment. So 9.7 arc seconds is the illuminated angular diameter in my particular image. You'll measure something different in yours. And then that's the illuminated angular distance. The angular diameter is going from point to point, tip to tip. And here I measure 31.4. So I'll enter that there. And the phase is just the small one divided by the big one. 9.7 divided by 31.4. And so in this particular image, I measure a phase of 31%. Okay. You'll need to do all of these. I'm going to do one more, and you can do all of them yourself. So let's look at this last one here, Venus 7. Again, we're looking primarily at sky glow. So I'm going to go back to the display settings and set it to bright target. And actually, if we come over here to the gear and select sync display settings, that will set all of your images to bright target. So you don't have to go back and do this image by image. Okay, let's zoom in on this. So it's very crescent in this picture. We'll go to the ruler, measure the illuminated angular distance going across here. I got 6.8 arc seconds. Put that here, 6.8. Then the angular diameter going from tip to tip. And I measured 50.8 arc seconds. So it's larger in this image, which means it's closer to Earth when this particular image was taken. That implies a phase of 14%. Okay. Now, you'll want to do this for all of the images and then go to the plotting tool, the graphing tool, and we'll want to select the Venus option. And here's that graph that you saw in the background section of Lab 3. So what are we plotting here? On the x-axis, we're plotting the angular diameter of Venus, and this is measured in arc seconds. Want to be sure to have the unit in there. And on the y-axis, we're plotting the phase. And this is dimensionless. There's no dimension to the phase. It's a fraction. Okay, so a good title for this might be phase versus angular diameter, or we can make it a little bit simpler, perhaps phase versus size. Either is okay. Of Venus. All right. And what we have here, these orange data points, when you first load this page, there's going to be some random data in there. We're going to want to get rid of that. So we can highlight and delete. And then we'll input our own data. So on the x-axis, we want angular diameters. Those are these numbers. The y-axis, we want the phases. Those are those numbers. So I'll just copy those and paste them in here. And we have 2 data points. And ultimately, you'll have 7 or 8 data points, depending on whether you got an image in Lab 1 or not. Now, if these data points cluster around the orange curve, we live in a heliocentric universe, and this is explained in the background section. In the heliocentric universe, you get this particular pattern of phases versus sizes. And if your orange dots end up primarily in the blue area, that means we live in a geocentric universe. So you'll be able to test and determine the nature of our solar system. Then when you're done, all you have to do is save it. So here you can save it as a PNG and upload that in WebAssign. And if the image is too large for whatever reason, you can also save it as a JPEG. It's a lower quality image, but a smaller file size. Okay, that takes us to the end of Lab 3.